Good day to you all. Today on part 221, we'll be looking at correlation analysis. At the end of this lecture, you should be able to define a perfect positive correlation, explain the theory and application of correlation in statistics, apply correlation theory to solving day-to-day business and economic problems. Correlation is a statistical measure that quantifies the relationship between two or more variables. It helps to determine the degree to which two variables are related or associated to each other. Correlation analysis is widely used in statistics, research, data analysis, dependencies, and trends in data. The correlation coefficient. This is a statistic which measures the strength and direction of the relationship between two variables, and it does this more precisely than the scatter plot. It is denoted by R. It ranges from -1 to +1, that is, R is greater than or equal to -1 and R is less than or equal to 1. A correlation coefficient of +1 indicates a perfect positive correlation, meaning that as one variable is increasing, the other variable is also increasing proportionately. A correlation coefficient of -1 indicates a perfect negative correlation, meaning that as one variable increases, the other variable decreases proportionally. A correlation coefficient of 0, that is when R is equal to 0, this indicates that there is no linear relationship between the variables. Let's consider the relationship between the amount of study time in an exam scores of students. When we want to know if there's any connection between the amount of time a student spends in studying and the scores such a student eventually gets in the examination. In the case of a positive correlation, a student who studies more will tend to get higher scores. If the student who studies more gets higher scores, the correlation coefficient is said to be positive. Conversely, if there is a negative correlation, it will mean that students who studied more might get lower scores. That's a negative correlation. If there is no relationship at all between study time and exam scores, then the correlation coefficient will be 0. It is important to understand that correlation does not imply causation. Even if two variables are strongly correlated, it does not necessarily mean that one variable causes the other to change. Correlation theory. This refers to the statistical analysis of the relationship between two or more variables. It is a fundamental concept in statistics and is used to determine the degree to which two variables are associated. Correlation is classified into three, as we mentioned earlier: positive correlation, negative correlation, and no correlation, which also means zero correlation. In the case of a perfect positive correlation, all the points lie on a straight line and they move upwards. This implies that as one variable increases, the other increases at the same rate. Perfect negative correlation. In this case, all the points lie on a straight line, but this time they move downwards. And this implies that as one variable increases, the other decreases at the same rate. Positive correlation. In this case, all points move upwards, just like the perfect positive correlation. All points move upwards. This implies that as one variable increases, the other also increases, though not at the same rate. This is the key difference between the positive correlation and the perfect positive correlation. Here, the increase is not at the same rate, while in the former, the increase of the two variables happens at the same rate. Negative correlation. In this case, all points move downwards. This implies that as one variable increases, the other decreases, though not at the same rate. That's also the difference between perfect negative correlation and a negative correlation. The fact that the increase or the decrease does not happen at the same rate is what differentiates it from a perfect negative correlation. No correlation. In this case, it is not easy to determine the direction of movement of the point, whether upwards or downwards, as they are completely scattered when plotted on a graph. The points are completely scattered. There is no particular pattern in which these points follow. The scatter plots shown below graphically represents all that we've been discussing. As you can see, plot 1 represents a strong positive correlation. Plot 2 represents a positive correlation, or sometimes called a weak positive correlation. Plot 3 represents a strong negative correlation or a perfect negative correlation. Plot 4 represents a weak negative correlation or a negative correlation. Plot 5 represents a moderately negative correlation, while plus 6 shows no correlation at all. As you can see, the points are all scattered all around the plot without a specific direction. With this, we have come to the end of correlation analysis. Thank you.